Okay, so now let us take a look at this example over here. So with this example, it says that a body is acted upon by forces F1, that is 10 newtons in the direction of 60 degrees, F2, that is 15 newtons in the direction of 210 degrees. Now we are to find the magnitude and the direction of the resultant force. So we are looking for the magnitude and the direction of the resultant force of the forces F1 and F2. Now we know that the resultant force is supposed to be so F1 plus F2. But then since it is given to us in the magnitude direction form, we cannot add directly. So unless we convert that to either the component form or the column form. So we are going to convert from the magnitude direction form to the column form. So if a vector is given in the form r theta, where the r is the magnitude and the theta is the direction, and you want to change that to the column form, it is going to be so r sine theta, then r cos theta, r cos theta. So that is what we are going to use to convert these ones into the colored form. So now we get r, that is a 10 times sine 60, that is the direction, then 10 times cos 60. So now this is going to give me 8.66 and 5. Then we do the same for the F2. So 15 times sine 120, sorry, sine 210, then 50 times cos 210. And that is going to give me negative 7.5 and then negative 12.99. So now I have the F1 and then the F2. Now to find the resultant, I just add them. So the resultant force is equal to F1 plus F2. So resultant means just add the available forces, just add them. So it's 8.66 plus negative 7.5 will give me 1.16. Then 5 plus negative 12.99 will give me negative 7.99. Then now we can find for the magnitude. So if the vector is given us 1.16 and negative 7.99, and we are to find the magnitude, we take the x component squared, then the y component squared. Then we take the square root of everything. So the square root of x component squared plus the y component squared. So don't forget to put this in the bracket so that the negative will be squared. So now this is going to give me 8.074 newtons, not units, newtons. So it is n, newtons, because we are dealing with forces. Then, so now we have the magnitude. So we are done with the magnitude part. Now we have to find for the direction. Now to find for the direction, we can draw our plane. Then we have the x component. We have the x component to be 1.16. We have the y component to be negative 7.99. So we find the x component over here, 1.16, it is positive. So we have the x-axis, we have the y-axis. So this is the positive part of the x-axis, and this is the positive part of the y-axis, and the negative part of the y-axis is here. Okay, so now we have negative 7.99 to be the y component. So you can see that it is written at the negative part of the y-axis. Then now we will find for this angle over here. Remember that anytime you are to measure your direction, we always start from the north. So we always start from the north, and the north is 0 degree, and we always move in the clockwise direction. So we will move in this direction over here till we get to our line. Now this angle over here is 90 degree. So in this case, all we need to do is to find for this angle which I am calling theta over here, add it to the 90, and then we are going to get our answer. So we need to find for our theta. Now you realize that with this, I have a right angle triangle down here. So this is a right angle triangle. That is a right angle triangle. Okay. Then when I take a look at this triangle, so it looks like this. While this over here is the theta. Now the length of this over here, that is the magnitude of this line over here, is 7.99. Now it is not negative 7.99, it is positive 7.99. Okay. Now the reason why it is positive is because I am taking the absolute of that value. I am taking the magnitude. It is the length of the line I am talking about, not the position over here. So it is the length of the line. So you cannot measure the length of a line and get negative. It doesn't make sense. So we ignore the negative part and we just write the positive. Then the length of this side over here is 1.16. So I have a triangle with theta, and then the adjacent is 1.16. The opposite is 7.99. So you can see that this side over here is the adjacent because it is next to our angle, and this is opposite because it is opposite to our angle, and this is the hypotenuse because it is the 90. It is the longest side of the triangle, and it is opposite to the 90-degree. So I can use tan and write this over here as the tan of theta is equal to, so opposite is 7.99 all over 1.16. Then I take the tan inverse. I get theta is equal to 7.99 all over 1.16. Then I do this on a calculator. I get theta to be 81.74. But 81.74 is not our answer. Now after getting this, now the 81.74 is this angle. So don't forget, we are starting with the measurement from the north. So this is the north. So we measure all the way till we get to this line. So we've gotten this angle over here. Now we need to add 90 to it. So 90 plus theta will give us the direction. That is going to be 171.7074 degree. So degree. So that is going to be our direction. So our magnitude is this, our direction is that.